But B11, right? So this is now going through looking at different molecules and then, assigning whether or not they're just simply resonance structures of each other or if they're completely different compounds. So the big difference, right, is that in a resonance structure, the overall bonding backbone is exactly the same, right? You don't move any sigma bonds. None of the atoms are moving in these cases, right? You're not adding a charge or taking out a charge. Right? In a resonance structure, all you're doing is basically moving around double bonds in those cases. So, or moving around like formal charges. Um, and so that's the thing to pay attention to, right? Is a bond changing like in terms of like how many atoms it's interacting with, or is it just simply you know uh, um, a movement of double bonds, and but all the sigma bonds are the same. So if we look at B11, right, the first one that we're looking at, right, the top left corner, what we can see is that those look like very similar compounds. But if we're going through it, right, this carbon right here only has a bond between that carbon and hydrogen, and then the double bond with the other carbon. Whereas in this molecule right here, right, it has a bond to two hydrogens, and then the other two carbons in those cases. So there's an additional hydrogen that's on that one right there for that specific carbon. So right off the jump, right, we can tell that this is a different compound, right? This isn't the same one. So even though, right, the double bond had moved from here to here, right, what you got is essentially that hydrogen right there, right, moved its way all the way up there. And because the hydrogen completely changed where its sigma bonds are, right, what it's bonded to, that makes it a completely different compound, right? They're not the same compound in that case. If we look at the one on the right, if we look at this, we have a formal negative charge on this oxygen right here, and then it moves to this oxygen right here. But overall, right, the backbone, the overall bonding framework doesn't change, right? None of the sigma bonds move. The only thing that moves is that double bond right here, right, essentially goes up there, and then this guy goes in there to form that double bond right there. Right, and so all it is just simply a movement of the formal charge in the double bond. None of the sigma bonds moved, right? So this is a resonance structure. We look at the ones in the middle, right, the one on the left. In this case right here, what we can look at is that over here we can see that we have an OH group, and then we here have a carbon that has two CHs, whereas over here that carbon now has three CHs, and this hydrogen or oxygen is now double bonded to that carbon and does not have a hydrogen. And another thing too, right, this one has two hydrogens right here, and this one only has one hydrogen right here. So there's not even the same number of hydrogens between the two of them, right? So that's, very clear indication that we're talking about something that's a different compound. Yeah, that's what I have right here. So next, right, if we're looking at the next thing, right, in this case right here, overall, right, the framework is exactly the same between the two of them. So we have a double bond between these two carbons, and then we have a single bond here between that carbon and that oxygen. There's a negative charge on that carbon, and then over here, what changes is that we now have a negative charge on this carbon, and then a double bond between that carbon and that oxygen. So the only thing that moved was the formal negative charge and the double bond between the carbon and the oxygen in that case, right? This carbon right here is still only bound to two hydrogens in that carbon. This one's still only bound to two hydrogens in that carbon, right? This carbon's only bound to that hydrogen and that oxygen, right? And that oxygen is still only bound to that carbon, right? So the overall sigma bonding framework is exactly the same. Nothing has changed. The only thing that's happened is that the formal charge is moved and the double bond is moved. So this is a resonance structure. So now if we look at the bottom left, right, what we're looking at here is that we can see that we have this carbon here. It has a positive charge on it. It's bound to two hydrogens in the oxygen, and that oxygen is then bound to that hydrogen. And then you can have, a change now where that positive charge is moved onto the oxygen, and you now have a double bond between the carbon and the oxygen, but none of the sigma bonds have changed, right? All of those are exactly the same in those cases. Right, you still have the exact same overall framework of that system. The only thing that's moved is the positive charge is moved, and now you have a double bond between the two of them. And that happens because if we look at the drew out the electron pairs on that oxygen, right, one of those electron pairs moves in to form the double bond in that case. So this is a resonance structure. Bottom right, the last one that we're going to be looking at, right, if we're looking at this right here, right, this is a CH3 group, this is a CH3 group, so those are exactly the same. you have a CO, you have a CO, that's exactly the same, right? You have, that's C2H3, C2H3, right? So the overall bonding is exactly the same between the two of them. So none of that has changed. Now, if we're looking at it, right, what we can see is that here we have a double bond between that carbon and the oxygen, and this carbon, right? And then now what happens is that we have a double bond between those two carbons, but now we have a formal negative charge here on this oxygen and a formal charge on that, or positive charge on that carbon right there. So in terms of the overall electrons, what happened is that all we did was just simply move the double bonds, right? The total number of electrons are exactly the same, because all it was is that we took, this double bond right here, and we moved it onto this oxygen. That's where you get then that negative charge on there. And then we just simply move the bonds from this bond into there, which then forms that double bond between those two carbons, but then makes that carbon all the way at the end a positive charge, right? Because now it has 2 less electrons than, or 1 less electron, sorry, immediately around itself to go there, right? And that carbon doesn't have a full octet, which, isn't preferable, but once you get to orgo, you start seeing those things more. But in terms of, resonance structures, right, they're both resonance structures with each other, technically. And that's how you approach, right, B11, right? Is you just have to really look at what's the framework. Does the overall charge change? Are you adding in electrons? Are you taking out electrons? And so forth, right? If any of those things change, right, then it's a different compound. If all it is you just simply rearrange bonds and moved around resonance, formal charges and stuff, then all you're doing in that case, right, is just drawing different resonance structures. So yeah, so that's everything.